Welcome to lesson 1.8, solving equations using algebra tiles. So I'm on page 38 and 39 in our textbook. The focus of this lesson is to use algebra tiles and symbols to solve simple equations in algebra. So if you recall from units that we've done prior, that one yellow tile represents one unit. And we call this a unit tile. So we've had some experience using unit tiles and representing integers, I think, with our unit tiles. However, we're going to be introduced to a new tile, and it's a long rectangular tile that is also yellow, and this represents x, or a variable, and we call this a variable tile. And we're going to use these two tiles to help us visually and pictorially solve equations using algebra. So knowing what each one of those tiles represents, I'm going to represent an algebraic expression with tiles, and I want you to see if you can tell me what expression is represented by these tiles. So this is my expression. So we know that each rectangular tile is a variable tile. So that represents x, 1x. And we know that each smaller square tile represents positive 1 or 1. So looking at this down here, what expression does this represent? So we see that we have two x tiles, or two variable tiles, and then how many individual unit tiles do we have? We have 5 individual unit tiles. So this model here represents the expression 2x plus 5. So I've put another example up of an equation that's modeled using algebra tiles, and then we're going to go through the steps in how do you solve this equation. And I put up an equation because, like we talked about a few lessons ago, you can't solve an algebraic expression. You need an equation in order to solve for the variable, and what I mean by that is just finding what the value of that variable is, or what number that variable represents. And I know that this model represents an equation as opposed to an expression because this line down the middle here represents an equal sign. So I know that I have two sides to my equation with an equal sign, so I know it's an equation. So the first thing we need to do, we're going to look at the left-hand side of our equation here, and we need to figure out what model does that represent, or what number or expression does this model represent. So I'm going to start by looking at my variable tile first. So I see that I have one long rectangular tile, which means I have one variable tile, which I'll use as x. And then I see that I have 3 unit tiles on this side, and I know that those all represent positive 1. So since I have 3, this model on the left-hand side represents x plus 3. I know that my line down the middle represents an equal sign, and now I'm going to see what my right-hand side of the model is represented by. So I see there's no variables on this side, but I see I have 1, 2, 3, 4, 5, 6, 7, 8, 9 unit tiles. So 9 positive unit tiles. So this model here is represented by the equation x plus 3 equals 9. So once I've established what my equation is, so I know that it's x plus 3 equals 9, I need to solve this in some way, and what that means is I want to figure out what number is that x. And I know we can all probably do this equation in our head and figure out what plus 3 equals 9. We know that it's 6, but we're learning how to show it using algebra tiles, so when we get to more complex questions, you can follow the same process to solve the answers. So what we would do with our algebra tiles is the general rule in algebra is whatever you do to one side of the equation, you have to do to the other side of the equation. And what I want to do is I want to get my x tile by itself because I want to figure out what does x equal. So I need to get the x on the left-hand side of my equation by itself. So I see I have 3 tiles here. And I don't want those 3 tiles there because I want the variable tile to be by itself. So what do I need to do? Those are 3 positive tiles. I need to subtract or get rid of those tiles. So I need to circle those 3, and I'm going to remove those 3. So like I said, whatever you do to one side of the equation, you do to the other side of the equation. So since I removed 3 tiles from the left side, I need to remove 3 tiles from the right side. So those 3 tiles are gone. And what am I now left with my equation? I can rewrite it out. So I have 1 variable tile, so x equals, and what do I have left over? 2, 3, 4, 5, 6. So now I know I've solved for x. X equals 6. So we're going to do one more example together, and this is an example from the textbook. So our question reads, Owen collects model cars. His friend gives him 2 cars. He then has 7 cars in total. So how many cars did he have at the start? So our first step is we need to develop an equation in order for us to model it using algebra tiles. So we need to read this and come up with our algebraic equation. So I know that 2 more than x, right? We want to know how many cars he had at the start. So how many cars did he have at the start? His friend gave him 2, and now he has 7 in total. So my x represents how many cars he had to begin with. The 2 represents how many cars his friend gave him, and 7 represents how many cars he has now. So this equation reads x plus 2 equals 7. And I'm going to say, how would you model this and solve this using algebra tiles? Again, I know we could figure out in our heads that 5 plus 2 equals 7, but we're learning how to show this using tiles. So x plus 2 equals 7. So on the left-hand side of my equation, I need 1 variable tile, and I need 2 unit tiles because that would represent my x plus 2. And then I draw my line, which represents my equal sign, and then I need 7 unit tiles on this side. 5, 6, 7. So now I've modeled my equation using the unit tiles. Like I said just a few minutes ago, we want to try to get our variable tile or our x by itself. We want to solve for x. X equals what? So I have 2 unit tiles here that I need to get rid of so I can have this x tile by itself. So I'm going to circle those 2 and I'm going to get rid of them. I've removed those 2. Whatever you do to one side of your equation, you have to do to the other side. So since I got rid of 2 on the right side, I need to get rid of 2 on the left side. I'm going to rewrite out my equation to see what I now have. So I have 1 x tile on that side, and I now have 5 unit tiles on this side. So what is that model? X equals 5. So we've solved, and just to double check your answer, you might want to put that number into the equation just to make sure it makes sense and double check your work. So those are 2 examples of how you use algebra tiles to model and solve equations.